My name is Joseph Putoff, and today I'm going to show you all one way of proving a pair of given lines to be parallel. Now, we are outside, and to begin my topic today, I would like to ask you all a question. What outside here would be considered two things, or two objects, that are parallel to one another? Well, one would be the sides of two buildings. They are parallel to each other. Another could be the top of one step and the top of the very next step. Those are parallel to each other. So now let's head back inside and let's begin our proof writing. Now I would like to go over some terms, theorems, and postulates that we may or may not be using in our proof. Our first definition is the definition of perpendicular lines, which states that perpendicular lines are lines that intersect to form right angles. A transversal is a line that intersects two or more lines in different points. Theorem 4.7 states that if two angles are right angles, then the angles are congruent. Postulate 4.14 states that if two parallel lines are cut by a transversal, then corresponding angles are congruent. Finally, postulate 4.15 states that if two lines are cut by a transversal such that the corresponding angles are congruent, then the two lines are parallel. Now that is just a few of the vocabulary terms that we may or may not be using in our proof. Next, we will be presented with the proof that we will need to prove. Now let's take what we have just went over and apply it to proving two lines parallel. So for our problem, we will be writing a two-column proof. We are given three lines, A, B, and C. We are also given that lines A and B are perpendicular to line C. So what can we do to prove lines A and B parallel to each other? Well, with A and B being perpendicular to line C, by definition of perpendicular lines, we have angles 1 and 2 are right angles. Then, with angles 1 and 2 being right angles, and using theorem 4.7, which states that if we have two angles being right angles, they are congruent, we can say angles 1 and 2 are congruent to each other. And finally, with angles 1 and 2 being congruent, and since C acts like a transversal, angles 1 and 2 are also corresponding angles. Therefore, because of this, by postulate 4.15, we have lines A and B are parallel. And there you have it. We have just proved two lines to be parallel using definitions we have learned in class. So that concludes this video of showing one way on how to prove two lines to be parallel. Until next time, I'm Joseph Putoff. Have a good day, and thanks for watching.